You may pause the video and try these two problems. Okay, I'm going to call this part A and call this part B. Okay, let's do part A first. Okay. Here we have 30 grams of sample. It's unknown sample, and it increases the temperature by 18.2 degrees Celsius. So we got change in temperature is positive because it goes up 18.2 degrees Celsius, and it absorbs that much of energy. If it absorbs it, it's going to be Q is going to be positive value, 1.34 kilojoules. Let's change it to joules. Multiply by 1000, so it's 1340 joules. So we have Q value here. What is specific heat? C is something that we had to figure it out. Okay, so we got the famous equation, thermodynamics. It's Q is equal to mass times specific heat times delta T. Okay, let's use this. So let's plug in numbers here. 1340 joules is going to be 30.0 grams, that's mass. Specific heat, we don't know. Multiply by delta T, it's going to be 18.2 degrees Celsius. So that specific heat will have the units of grams, joules, and Celsius in it. Okay, let's solve for C here. So C is going to be divide these two numbers. So we got 1340 joules divided by 30.0 grams, also divided by 18.2 degrees Celsius. So our unit's going to be joules over grams over Celsius. That's the unit for specific heat. And all we need to do is divide using our calculator here. 3 sig fig, it's going to be 2.45 joules over grams over Celsius. That's our specific heat. Okay, so knowing that, let's go ahead and do part B. Part B says it's the same unknown. We have different mass here, okay, 15.6 grams, and we have different Q here. It absorbs 868 joules. Initial temperature is going to be 21.5. What is final temperature? Okay, so we have a specific heat value here from earlier example. So we got Q equals mc delta T again, but we know Q, we know M, we know C. Delta T is something that we have to figure out, okay? We know that delta T is going to be T final minus T initial. They gave us what the initial value is, so all we need to figure out is T final. Okay, let's plug in numbers here. It's already in joules. Make sure that units match here. Okay, so it's 868 joules is going to be mass 15.6 grams. Specific heat, we got it from earlier example. It's going to be 2.45 joules over grams over Celsius, and then times by delta T. Let's, you know what? I'm just gonna solve for delta T first, okay? So delta T is going to be, just divide these two numbers from 868. So we got 868. Units will cancel out, so I'm not gonna write the units right now. Over 15.6 over 2.45. Let's see what that comes out to be. It's going to be 22.7. If I keep going, it's 106 on and on, but it's 3 sig fig, so I'm going to underline. So 7, up to 7 is my sig fig. Now let's do delta T, which is equal to T final minus T initial is 21.5. That's equal to 22.7106, and on and on. Okay, now I'm going to add. So T final is going to be 22.7, that's my sig fig, 106 and on, plus 21.5. Let me shrink this a little bit. And it's going to be 44.2106, and on. But here's the thing, since we added, we have to keep the least precise as our sig fig. So least precise for this guy was tenths right there. Tenths. And remember from earlier example when we multiply and divide everything, our suffix was up to tenths as well. Okay, so we have to keep our answer into tenths. So we have 44.2 degrees Celsius. That should be our T final.